Hey, Bio2 students, Mr. Yance again. Hope you're doing well. We're going to kind of continue on with mitosis, chapter 12 notes, day 2. So kind of just jump right in here. In 1882, a German anatomist named Walter Fleming developed dyes to observe chromosomes during mitosis and cytokinesis. And that kind of really got the ball rolling on our knowledge about how cells go through life. Now, he wasn't totally right on his theory. He thought that cells appeared to grow larger between one cell division to the next. We know that that's not true today. We know that in actuality, there's some major critical events that take place during the life cycle of a cell. And when we look at those events, we know that there's a sequence to them. There's some time to them, and they're always consistent how they go through that. So we're going to start with interphase. This will be page 2 on your foldable. So what I have in red for the next several note periods, highlight, and we'll put those in our foldable. Okay, so this is going to go on page 2. You're going to take cut out the picture of interphase, the color sheet one. I have a label for you on that first page, and then we're going to write some of this stuff in red on that same tab. Okay, so interphase is 90% of the cycle of a cell. So if you look at this blue, think of it a pie. 90% of that pie is going to be in interphase. So since it's such a big part of a cell cycle and such a long part of the cell cycle, we divide it up into 3 subparts, okay? And this should sound familiar. In fact, I copied and pasted this right from your Bio 1 notes. So we have G1, S, and G2. That's the 3 things. So let's kind of break that down. So in G1, you can see on the screen that the cells grow, they mature, they just do normal cell stuff. So you're going to see mitochondria and Golgi bodies and nucleus and nucleolus and all those normal cell parts like we talked about in the last chapter. You're going to see a cell do what a cell does. Blood does this thing, skin does this thing. So G1 is just the growth and maturity part of the cell cycle of interphase, okay? Now, S phase, a big critical event occurs, okay? And that is this DNA copies itself. This we don't want to gloss over. This is a really important part to cell division. So we're going to go from a parent to 2 daughter cells. And those 2 daughter cells have to have the same information. So if I want more blood, if I take that blood cell and it splits into 2 blood cells, I got to have the same information in both of those. So what happens is a cell copies its DNA. And there's a brief period that we have 2 copies of DNA in that cell until that cell gets ready to divide. Okay? And in the G2, it just continues to grow, mature through all these phases. It's doing normal cell stuff, 90% of a cell's life. And then it's getting ready for cell division. So think of this like, we're having a big dinner. The table is set. Everything's laid out on the table. We just haven't eaten yet. And that's basically what the G2 phase is. It's setting the table. So as you can see from this picture, this big blue area is the G1, S, G2, not equally distributed. The S phase is a little smaller than maybe the G1 and the G2, but this is where a cell is going to spend most of its life. Now, here's the thing. I don't know if you guys remember this, and this is what we're seeing, a normal cell with a nucleus, right, and a nucleolus and all that good stuff. Remember that interphase is not a part of mitosis. Mitosis is just that little sliver of pie where we're going through prophase, metaphase, anaphase, telophase. Interphase isn't part of that. Inter means between phases. So this is the period between one division to the next. And that's going to vary depending on what that cell is, how long it spends in that. But understand that interphase is not part of cell division technically. However, without it, it precedes it, and it has to have DNA make a copy, or none of this is going to work. All right, so just kind of understand that. I want to make sure everybody's clear on that, and we don't forget that. All right, now, a very critical part that I kind of want to finish up, so short notes today. A cell can exit the G1 phase and enter what we call the G0 or GO. I've heard it called both. And that's where a cell does not copy DNA and does not ever divide again. So once you reach full maturity, your brain and most of your brain and part of your central nervous system, I should put the heart in there too. Once you reach full maturity, those cells will never divide again. Now think about that for a second. So once you're 18, 19, that range, you're stuck with all your heart cells. You're stuck with all your brain cells. You're not going to get any more, okay? In fact, you're born with all the brain cells you're ever going to have. It just goes down in number. So this G0 is an important concept to understand, and that's why I don't like. I'm a CPR instructor, and I hate when people say, "Well, they had a mild heart attack." There's no such thing. If I damage 10% of my heart, it's damaged forever. So I only got 90% of my heart left. If I damage my brain, it's gone forever. I'm going to have less capacity from that point forward. So that's why I think sometimes you guys involved in athletics and things like that, you think we get a little crazy with concussion protocols and things like that. We have to be, because if that brain and that heart gets damaged, they're in that G0 phase, GO phase. They're never going to divide again. And you can see why we're putting so much research and money in figuring out, what if, think about this, what if I can trigger those cells to turn back on? That would be big in medicine. If we could get somebody that's 60 years old and has a heart attack and damages their heart, and we could turn those heart cells back on and say, hey, put those back like we do blood and skin, that would be big. Not there yet, but we get there hopefully. But that's kind of where we're at with some of that research. All right. Okay, so that's just kind of the interphase, the setup. We're going to go through the 4 phases of mitosis in the next section of notes. So, hey, have a great day. Just like always, if you have questions, shoot me an email. Stay safe and have a good rest of the day. We'll see you. Bye.